You've got a list of flights, each one from city A to city B. One city is the final stop with no outgoing path. Can you find it faster than checking every city against every other city? We're given a list of paths where each path is a pair of strings, a source city and a destination city. The paths form a straight line, no loops, no branches. The task is to return the one city that appears only as a destination, never as a source. That's the final destination. The challenge is to avoid scanning the entire list for every city. The naive approach is to grab each destination city and scan the whole list again, checking whether it ever appears as a source. If it doesn't, we return it. This works but does redundant work. We're rescanning the same source cities repeatedly. For n paths, each check takes linear time, leading to n squared time. Space is constant since we use no extra storage. Fine for tiny inputs, but we can do this in a single pass. The key insight: the final destination is the only city that appears exclusively as a destination, never as a source. So instead of checking each destination against all sources, we first collect every source city into a hash set in one pass. Then in a second pass, we check each destination against that set. The first destination not found in the source set is our answer. We iterate the paths once, adding each source to the set. Then we iterate again. For each path, we grab the destination. If the set does not contain that destination, we return it immediately. This guarantees we find the unique dead-end city. The code is simple. Declare a hash set of strings. Loop through the paths, adding the first element of each pair. Then loop again, and for each second element, if it's not in the set, return it. If we somehow finish without finding one, we return an empty string, but the problem guarantees there's always one. Let's trace it on the example. London to New York, New York to Lima, Lima to Sao Paulo. First pass, we build the source set, we add London, then New York, then Lima. Our set now contains London, New York, and Lima. Second pass, we check destinations. First path destination is New York. Is New York in the source set? Yes, so skip. Second path destination is Lima. In the set? Yes, skip. Third path destination is Sao Paulo. Is Sao Paulo in the source set? It's not. So we return Sao Paulo. That's the city with no outgoing flight. The output is Sao Paulo. It's the only city that never appears as a departure point, so it's the final destination. You'll spot this pattern when you need to find the one element that never appears in a certain role, especially in paired data where relationships form a chain or a tree. Also when the problem asks for the sink, or terminal, node in a directed graph that's guaranteed to have exactly one endpoint. Time complexity is big O of n because we do two linear passes over the paths. Space complexity is big O of n for the source set, which in the worst case holds every city except the destination. Try the next problem, same pattern, finding the node with no outgoing edges. Subscribe for more clean, no-nonsense solutions.